Hello, everyone. Welcome to our September cut flower growers meeting. This month, we're hearing from Nick, who is the new, you've been in the position for a bit now, but an extension, horticulture, and specialty crop field specialist with SDSU. So he is going to introduce himself and then jump into his presentation.
Yeah, thanks for having me, Morgan. So yeah, like she said, my name's Nick Volesky. I'm the new Extension Horticulture and Specialty Crop Field Specialist with South Dakota State University Extension. I've been in this role for almost 3, 4 months now. I started at the end of July. So a little bit about me. I'm originally from North Platte, Nebraska. I'm about 5 hours south of here. I went to the University of Nebraska in Lincoln, where I got my bachelor's degrees in applied science and horticulture. And after graduating there, I went out to Utah for several years, where I worked with Utah State University Extension. I worked with the Integrated Pest Management Program, mostly working with specialty crop producers in the state. Um, but towards the end of my time there, I had the opportunity to go back to school and earn my master's degree, which was focused on cut flower production. So a lot of my expertise now that I bring here to South Dakota includes IPM and specialty crops, optimizing vegetable and cut flower production, and protected cultivation. So I moved here with my wife Hannah, our two Devon Rex cats, Olive and Juniper, and then we're expecting our baby in the next couple weeks, sometime in October. So she will be a native South Dakotan, which will be fun. So I'm excited to talk to you guys about what my research was out in Utah. And a lot of this information I'm hoping can be applicable to South Dakota growers as well. So my thesis was titled Optimizing Delphinium and Larkspur Through Timing and Protected Cultivation Methods for Cut Flower Production. So that's a mouthful, but we're going to break it down. So I'm going to talk about what some of the research needs and kind of the background information was for this project. And then we'll focus on delphiniums, and then we'll focus on Larkspur. And then I'm going to talk about some of the extension outputs that I did and kind of what I want to do for some extension programming goals with our cut flower producers here in South Dakota as well. So let's look into the background information. I'm sure a lot of you guys are familiar with cut flowers as you guys are growers yourselves. Um, in 2022, the USDA reported just over 9,500 farms in the country, and they produced on over 31,000 acres of unprotected field space, which is really cool. That's a lot. And that same year, cut flowers were valued at over $760 million in annual sales. And that was a 33% increase from what we saw in 2017. And now, as we approach 2026, I bet those numbers are even greater. So I'm excited to see the data come out. We can also see a lot of growth in cut flowers through memberships, like the Association of Cut Flower Growers, which is kind of the national organization. In 2020, there is less than 2,000 members, but we saw 46% growth to close to 3,000 members. So just exploding. Um, in Utah, where I did this research between 2012 and 2017, Utah actually lost just over 17,000 acres of farmland. And that's just mostly due to urbanization and population growth. So if you're kind of familiar with Utah geography, most of the state's just federal land, it's uninhabitable, and most people live kind of along the urban Wasatch Front, we call it, and that's kind of a lot of where that farmland was getting lost. But despite that land loss, there was actually an increase in the number of farms. Um, where as that land was getting subdivided, the farms were becoming a lot smaller. So 34% were operating on just under 10 acres. Um, in Utah, there was only about 15 cut flower farms back in 2018, and the latest data in 2023, there was close to 200. So that's well over 1,000% increase. Again, you can kind of see from this county map, a lot of those farms were concentrated along the urban Wasatch Front. And we also saw a lot of growth in the Utah Cut Flower Farm Association, which is kind of a similar group as this one right here. We saw a 112% increase from 2019 to 2023. So it's really exciting to see that growth in Utah. So I was kind of curious about South Dakota as well, and there's really not a lot of data to pull from. So I mostly pulled from our Specialty Crop Association, kind of all the cut flower farms we have documented here. Cut flower farmers love to use Instagram, so I would go on Instagram. I know I messaged a lot of you guys and reached out. That's kind of how we coordinate farm visits. I think Instagram and social media is a great platform for your businesses. So I found farms that way. The National Association kind of had somewhat of a database. And then the slow flower movement kind of also had some records. So kind of just referencing all those sources, there's about over 30 to 35 cut flower operations in the state. So I kind of tried to map them out by county. So again, this is not super set in stone. I know farming's really fluid. So I would love to kind of maybe work with the association and the cut flower group to kind of update this map too, so we can let consumers know where you guys are located. But it is cool just to kind of see the concentration, especially along that I-29 corridor as well. In 2022, the USDA valued South Dakota cut flowers at just over $75,000, which is great considering that on such small amount of acreage that they're grown on. This is really a high value premium crop. Um, and I'm hoping we can get more reliable acreage data too on the amount of space that is being dedicated to cut flowers here in South Dakota. So some regional production challenges that we had in Utah, and a lot of these I think can cross over to here in South Dakota as well. A lot of growers tend to favor the warm season annuals like Cosmos, Zinnias, because we do have a lot of challenges with cool season crops. Utah has high elevation and a lot of microclimates, and that can bring some late or early snow. There's a really short growing season, usually about 89 to 135 days where you are located. And there's really big day to night temperature differentials. So we sometimes can have a 20-degree temperature swings. And of course, there's really intense solar radiation once you get in higher elevation. And usually by the late spring, a lot of growers were dealing with the heat. There's a lot of pests and pressure and plant diseases that can arise. And some areas might have water restrictions as well. So I think kind of the same story with South Dakota is we really don't have a lot of guidelines for a lot of the guidelines that do exist are for other production regions, kind of in up in the Pacific Northwest, kind of the East Coast. They really don't address Utah's or even South Dakota conditions as well. So we really need to kind of figure out some local solutions that we can use. So one option that a lot of growers use is protected cultivation. So this can include high tunnels. And we know that high tunnels are great to increase stem length, yield, and the harvest timing. In northern Utah, our lab found that high tunnels advance peony, anemone, snapdragon, and ranunculus by up to 34 to 56 days. So that's up to 2 months of getting your flowers sooner than what you would in a field system. With high tunnels, the air temperatures, they can also be up to 30 degrees Celsius warmer. If you vent them, they can be 10 degrees warmer. But usually at nighttime, they're only about 1 to 3 degrees warmer from the night versus the inside during the day. So they are passive solar structures. That's an important thing to remember. Another option that I've seen a lot of our South Dakota farmers use is the use of shade cloth. So shade cloth's great because it can help reduce surface temperature and can really increase our stem length with our flowers. So why did I focus on Delphinium and Larkspur? Well, these are both cool season crops. They're closely related. I think sometimes people even use the terms interchangeably, but they are different flowers. They're both within Ranunculaceae, and they really have strong market potential. I know in Utah, the local demand really exceeded what supply was available. Prior to my research in 2022, I reached out to 62 growers. 72% said they currently grow Delphinium and Larkspur, and 21% said they were definitely interested but not yet producing. So this crop was definitely a strong choice. Research was needed to develop kind of reliable production methods and figure out how we can extend that harvest and boost the yields. Um, Cut flowers also have really great profit potential as well. So in Utah, they really redefined profit margins, especially when those regional production guidelines were implemented and optimized. So in Utah, the average gross revenue per acre was about $64,000, which is phenomenal, right? That's way more than corn, soybeans. Like we can really get the most money with this crop. Um, so I apologize. So a lot of my units will be in meters square, but just know that that's about 1.2 yards squared as well. So pretty similar. So with high tunnel ranunculus, we found the profit per meter squared was close to $54. Anemone was $37. Snapdragon was close to $28. And then field peonies were most optimized, and those were close to $26 as well. So we really had a lot of cool economic data that we could pull from Utah. And this is something I think that would be really interesting to model for our South Dakota growers and kind of figure out what the market is like here as well. So now let's dive into delphiniums. So kind of the title of this section is Advancing Harvest and Increasing Yield of Delphinium Cut Flower Production Through Transplant Timing and Protected Cultivation in the U.S. Intermountain West. So um, I guess you guys can comment. I'd be curious if you guys grow delphinium on your farm. But the cool thing about delphiniums is they're short-lived, cool season perennials. Um, when we're growing them in cut flower production, they usually only are good for about 1 to 3 years. A lot of homeowners might grow delphinium in their yard and they can last several years. But in cut flower production, we're chopping them down, so it's a lot more intensive. So that kind of spends the plant out a lot more. Their optimal temperature is about 65 to 75 degrees Fahrenheit during the day, 58 to 61 degrees at night. Delphiniums come in a lot of cool, unique shades of blue that we don't see a lot naturally in nature. They have these tall racemes and they can offer vertical structure and balance to floral arrangements. So the two kind of main delphiniums are the Delphinium elatum types. So these are the more large stereotypical delphiniums you might think of. They have the densely packed racemes of flowers. And then there's the belladonna type. So this is a hybrid. So these are kind of the more airy, loosey ones. And these are the ones that I typically see more kind of in florist shops or grocery stores. Um, and in Utah, the average price for 5 stem bunches of elatum types was about 240 to 320. And then the belladonnas would get bunched in 10 stem bunches for 120 to 160. So again, we didn't really have a lot of regional production guidelines for delphiniums. So there was some prior work and research on delphiniums, looking at early transplants and the use of high tunnels. So in Lincolnshire, out in the UK, they're in hardiness zone 7B. They have about 204 freeze-free days. So they found that late March transplants had the greatest yield at about 45 stems per meter squared. They also found that staggering the planting from late March to mid-May yielded stems early as late June through October, so about a 17-week window. In Ithaca, New York, in Zone 6A, they have about 144 freeze-free days. So in their high tunnel production, they could get about 1.7 to 4.6 stems per plant in the high tunnel, which was way more than in the field where they'd got just about 1 to 3 stems per plant. So it's really cool to see that high tunnels advance the production by up to 2 weeks almost. So this was something I was excited to kind of replicate and try in Utah. So it's kind of the objectives with this delphinium work was to assess both high tunnel and field systems for bloom timing, yield, and stem quality of first and second year plants. So I was going to test 2 spring transplant dates per system. So in the high tunnel, I was going to transplant in late March and mid-April, and then early May and mid-May in the field. So just kind of as the frost and freeze risk was ending. So I looked at 3 series of Elatum and Belladonna types, and then within each series, 3 different color selections. I also wanted to evaluate if shade cloth would be effective. So I did that out here in the field system, and I used 30% shade cloth. And you can see that delphiniums, they're big plants. So I had to make the low tunnels a little bit higher. So I had to extend them up just to support those big delphiniums. So here are all the series that I grew. So the Delphinium elatum was the Magic Fountain and Pacific Giants. And then I had 3 colors of the Belladonna hybrids. So like I was saying earlier, you can kind of see the difference between the two, where these elatum ones are more of the stereotypical dense ones, whereas the Belladonna are more of the airy ones as well. So my research happened in Logan, Utah at the USU Research Farm, and I conducted this 2 seasons, so in 2023 and in 2024. So we had a silt loam soil there, about 2% organic matter. And then we were about 1,300 meter elevation, which I think is about 1,000 feet more than here in Rapid City. We were in hardiness zone 6A, and we had about 135 freeze-free days on average. So our season's usually mid-May to the end of September. So I had different high tunnels I worked with. So I I'll touch on that here in a second on kind of the details. But I did high tunnels and then field. So everything was kind of on the same farm site. So for my analysis, I did statistical analysis with the p-value at 0.05, which is pretty standard across agricultural research. I did prox-limix, and then I did an ANOVA type mix model to compare the different interactions, and I'll touch on that more when we get to the results. So for my experiment design in the high tunnel, I had 2 tunnels. So I'm comparing the first year of delphinium growths to the second year of plant growth. So the first year I transplanted them, and then the second year I did all new transplants. So it was a fair comparison of first year plants to first year plants. But I also evaluated the second year growth of those original plants in 2024. So you'll hear me talk about first year plants and second year plants. That's the difference. So in the high tunnel, I had kind of a split block design where I had 4 sections that were based on the planting date, either late March or early April. And then in each of those blocks, I had the 3 series that were further broken down by the 3 different colors. So everything was equally represented. Same thing in the field where I had the 2 different planting dates with the 3 different series and 3 different colors within that equally represented. But then there's the added layer of the shaded plants on the north side of the field versus the unshaded or full sun plants out there as well. And then, of course, I added a second field for the 2024 first year plants as well. So everything was equally represented. I couldn't statistically compare the field system and the high tunnel system. So, but we can talk about the 2 systems and kind of compare and contrast in that sense. So to get started, I ordered my seeds from GeoSeed supplier. I know there's a lot of delphinium seed suppliers out there. And for our practice, we chilled the seeds for about 3 weeks prior to sowing in the greenhouse at 36 degrees Fahrenheit. So we sowed them in about a peat-based media in containers like this. And then I started them in 128 count cells in kind of a tray, and then I would upgrade them to these 32 cell trays pictured here. Usually about 21 days after they germinated, when there was about 2 to 4 sets of true leaves. So the greenhouse was a controlled environment, so we were able to maintain the temperature at an optimum 64 to 72 degrees Fahrenheit with no day-night differential. They were irrigated daily. Fertilizer of 12-5-20 was applied at 100 parts per million nitrogen. And then we had supplemental lights for about 6 hours per day. So that was about a 16-hour total photo period. And then plants were hardened off outside at about 7 to 10 weeks after sowing. So then we started to transplant them. So the spacing was about 1 foot apart. I used a horizontal trellis, and that was just applied at crop height and kind of adjusted as they growed. I irrigated 3 times per week, so I would have 4 lines of drip tape. They were about 1.5 feet apart in the beds. And then the high tunnels, it was really important to manage the temperature because they can get really hot, especially in the springtime. So the windows were open on days where there was 400 watts per meter squared of sunlight and the temperatures were greater than 40 degrees Fahrenheit. We opened the doors when the temperatures were greater than 60 degrees, and we would lift up the sides on days when the temperature was above 75 degrees. So usually kind of towards the end of May, we would swap out the plastic and put shade cloth on the high tunnels as well. So for fertilizer, the phosphorus and potassium and iron were just applied based on soil tests and tissue tests of the plants. And then nitrogen, we actually applied at 150 pounds of nitrogen per acre in 3 split applications. So you're probably thinking that's a lot of nitrogen. That's almost kind of the same level that field corn uses. But this was very justified and important because delphiniums, they are really big plants, and we found that they are really heavy feeders. Um, and here's kind of the timeline of when I did those nitrogen applications in both the high tunnel and in the field. So kind of the fun part, the data collection. So temperature was a really important component. So I had the reference air temperature and precipitation from the farm weather station that I reference at the end of the season. I also use data loggers to measure the temperature at the plant canopy height, both in the high tunnel and field system. And then I would bury them a few inches into the soil to kind of see what the root zone was experiencing in terms of temperatures. So these are all measured hourly throughout the year, especially looking at March through October. I conducted stand counts to kind of help with the statistical analysis, make sure everything was calculated fairly. So I did that 2 weeks before the first and second flush harvested. So I would harvest at 3 times a week. And usually with delphiniums, we do that when 1/3 to 1/2 of the raceme is open. And then I would grade them. So marketable stems were then defoliated and then I stored at 2 degrees Celsius with preservatives. Sorry, I forgot to convert that. I think that's 36 degrees Fahrenheit. And then we actually sold our delphiniums through a local cooperative and farmer, mostly to markets along the Wasatch Front. So they were about $12 to $16 per bunch. So take a look at this grading scale I have. So for delphiniums, anything less than 16 inches, we considered cool, not really marketable, so we would toss that. And then the basics grade was about 16 to 24, so this was the lowest tier. Standard was about 24 to 36 inches, and then premium stems were anything greater than 36 inches. So this is the most desired because we know that buyers and florists, they really want those long stems that they can use. So kind of looking at the results now. So it's important to really understand the environmental conditions. So I put this table together looking at both 2023 and 2024 climate data, looking at the average, minimum, and maximum average temperatures from March through October. And note that these temperatures are in degrees Celsius, not degrees Fahrenheit. But kind of remember, like I said earlier, the optimum temperature for delphinium growth is about 58 to 75 degrees as well. So I was looking at the reference air temperature from the weather station. I looked at the canopy air temperature, and then in the high tunnel and field, I looked at the amount of precipitation we got during that time. And then, of course, the soil temperature, which I have on a different table. But some key takeaways were I calculate the number of hours that the delphiniums were experiencing that optimum temperature. So the number of hours they were within that 58 to 75 degree range. So in 2023, from from April through May, during right after transplant in the high tunnel, they were had 269 hours in 2023 and only 445 hours in 2024. So they had way more hours of optimum temperature in 2024, which will be interesting and something I tie into here in a second. In June, the average field temperature was slightly warmer in 2024 than it was in 2023. And then the optimum hours, the field, again, similar story. There was only 228 hours in June that were optimal and 304 hours in 2024 that were optimal for those field plants. So in terms of temperature, 2024 was quite a bit better for them. So kind of let's look at the timeline now. So what we're looking at is the cumulative marketable yield of the delphinium measured in stems per meter squared. So remember, that's kind of similar to a yard squared. And then we're looking at that compared to the date during the growing season. So I have these broken up into the first year plants from 2023 in the high tunnel and in the field, the first year plants in 2024, and then those original plants from 2023 that become the second year plants in 2024 in both the high tunnel and in the field. So the color of the lines represent the three different series. So blue was the Belladonna, orange was the Magic Fountain series, and green was the Pacific Giant series. So the solid line represents one transplanting date, and then the dashed line represents the other transplanting date. So the solid one is the earlier one, which was late March in the high tunnel or early May in the field. And then the dashed was mid-April in the high tunnel and mid-May in the field. So the symbols represent the two different flushes. So the red was the first flush, blue was the second flush that occurred. And that's further broken down by when about 10% of the harvest, 50% of the harvest, and 90% of the harvest occurred for those two flushes. So just kind of stepping back and looking at it visually, you can see that um, the cumulative marketable yield total throughout the season, you can kind of just see those when those two flushes occurred more easily in the second year plants, I think. So again, some key takeaways from this data was that the second flush is longer, had a longer duration than and a higher yield than the first year flush, almost 1 to 4 weeks longer and 3 times greater. And that actually makes sense for delphiniums because when we're harvesting it, you first transplant it, that first flower you're going to get is just going to be a single stem. But once you cut it, you're going to get multiple subsequent stems that come from that. So it makes sense that our second flush will be a lot greater. So in 2024, the harvest in the high tunnel was up to 3 weeks earlier than what it was in 2023, which is really cool. So you can see that right here. So the harvest started a lot earlier in June compared to end of June. So that correlates to the climate data I just showed you, where the temperatures were a lot more optimal in 2024. So we got a lot sooner of a harvest. So that's kind of a cool visual to see. And then we also found that the second year plants versus the first year plants had 2 times more marketable yield. So by the time the delphiniums are in their second year growth, they're producing a lot more and they're producing a lot sooner as well. Because look at this, in the high tunnel, May 10th was when we had that first harvest. So it was really cool to have delphiniums already in May 10th in the high tunnel. So we could possibly hit markets like Mother's Day, and other events that happened that early in the season. And then similarly in the field harvest occurred 6 weeks earlier as well. So, but staggering all these together with the different transplant dates, the first year plants and second year plants gives us a whole 22-week window of just continual delphinium supply, which is great marketability for our buyers. So now let's look at some of the high tunnel total yield overall. So we're looking at the total yield, again, measured in stems per meter squared compared to our treatments. So on the left, we have the late March transplants versus the mid-April transplants, looking at the first year plants in 2023 and 2024, along with the second year growth in 2024. So one of the first things, and then the colors represent the 4 different grading standards. So the dark blue is premium, mid blue is standard, light blue is basic, and then the orange is the Coles. And then the letters actually represent the significance. So this is kind of where that P 0.05 value comes in. So the capital letter, the top letters represents the total marketability, including the orange section. And then the bottom sets of letters represent the marketability of just the marketable, so only the blue sections. So the big letter we're comparing internally. So we're comparing to the three different series within a transplanting date. So for example, we're comparing Belladonna to Magic Fountain versus Pacific Giant within just the late March planting date, or we're comparing those series within just the mid-April planting date. The lowercase letter represents significance compared to um, the two transplanting dates with each other for just the series. So comparing the late March Belladonna to just the mid-April Belladonna. So that's a little complicated. I can touch more on that if we have questions. But kind of looking at the big picture, right away we can tell that Belladonna almost always had greater yields than the Magic Fountain and Pacific Giants, which were not always necessarily significantly different, but you can just see visually as well. And we also found that the second year plant throughout the season with those second year plants, which is really cool. So, there was no significant difference between the transplanting dates in the second year versus there's no significant difference between those transplanting dates in the second year, which makes sense, right? Transplanting really only mattered in the first year. By the second year, they would have caught up to each other. So some of the differences are mostly just correlated with the survivability of the plant as well. So now let's look at kind of the same thing in the field. So similar layout of these graphs. So we're looking at the total yield in stems per meter squared compared to the different planting dates in the series. We're looking at the first years and then the second year plants. But now we're looking at the no shade treatments versus the shaded treatments. So some takeaways are that the field had a lot lower yields, more coals than the high tunnel. Which makes sense. So they were a lot more exposed, so they experienced a lot more damage. Um, Same series and transplanting dates trends across both systems, which was interesting. So this really tells us that there's really not much of a difference with the shade treatment that we found, which I'll touch on more in a bit. But again, compared to the high tunnels, the field just had a lot more lower yields. So overall, with the delphiniums, we found that the high tunnels advanced early season, 2 to 5 weeks sooner in the high tunnel. We could get about 25 stems per meter squared in the high tunnel, whereas in the field we only got about 8 stems per meter squared. And of course, the high tunnels that protected cultivation really allowed for improved stem quality. In the high tunnels, about 31% were premium, and in the field we only had about 13%. But like I was saying, combining both those first year and second year plants across both systems, you can get that continual supply all the way from early May through mid-October for about 22 weeks. Transplanting in late March, that equaled the greatest yields and the stem quality and had the best projected gross returns. So kind of if I were to continue doing this research, I would want to evaluate possibly even earlier transplant dates in the high tunnel and see how soon we can go and kind of maybe do some controlled agricultural environment studies and kind of determine what the lowest temperature threshold is that young delphinium transplants can handle. So now let's switch gears a little bit and talk about Larkspur. So my research was really similar with the Larkspur. It was on protected cultivation and early sow dates to improve the growth, yield, and quality of Larkspur production. So Larkspur, I always call them Delphinium's little cousin. So these are cool season annuals. They only grow for 1 year. The most common cultivated or cultivar for cut flowers was the Consolida ajacis. Um, they have kind of a more tight optimal temperature window, about 60 to 70 degrees. So similar with the delphiniums, florists like to use them for that focal vertical line arrangements. They can kind of, again, come in those popular blue to gray kind of colors and hues. Um, in Utah, we would bunch 10 of the primary stems for about 90 cents to $1.30, or you could bunch 15 to 20 of those smaller secondary stems for about 75 cents to $1. So again, we really didn't have a lot of regional production guidelines for Larkspur. So some of the objectives, or sorry, some of the prior research with Larkspur was they found that earlier planting advanced a harvest, but there was a risk of yield loss from those suboptimal temperatures. So almost growing it too early was the problem. So at Cornell University in Ithaca, Zone 6A, 144 freeze days, they found that high tunnel larkspur that was transplanted, not direct sowed, in early May had a first harvest around mid to late June, and then their stem lengths were just under a meter. They also found that the cane's deep blue color specifically transplanted in April, they could get that 7 to 10 days earlier than the late April um, but there was a lower yield. So again, that could be affiliated with those suboptimal temperatures. And they would get about 4 to 4.5 stems per plant. Kind of my objectives with the Larkspur, again, I want to assess both the high tunnel and field system, looking at the bloom timing, yield, and stem quality. I want to look at direct sow dates. So that's kind of an important thing to know. Larkspur does a lot better when we direct sow it, as opposed to trying to start it in a greenhouse or inside and then transplanting it. So I wanted to direct sow it in mid-March and late April in the high tunnel system, late April and early May in the field system. So similarly, I was looking at 3 different series with 3 different color selections within each of those series. Again, let's test the shade cloth. So I did the 30% shade cloth in the field versus full sun treatments. So here's all the Larkspur that I tested. So I had the Cane series, the QIS series, and the Fancy series. So there's again different color variations. And I guess I should have clarified more. So series is kind of just a marketing term where these are different colors that grow and behave similarly within a series. So if you're going to buy Delphinium or Larkspur, you might see them as series like Canes, QIS, the Magic Fountain, Pacific Giant. So the only unique thing was the Fancy series where these really didn't behave similarly. And the Belladonna Larkspur is interesting because this was 100% single blooms. Whereas a lot of the other Larkspur, if you look on the C label, it'll give you kind of an estimated percent of what single blooms there are because they really are mostly just the double blooms. So that was kind of another thing to consider too, and I might touch on here later. So here's the experiment design. So similar with the Delphinium, I did the high tunnel. I broke it up into a split block design where half the blocks were the mid-March planting date and the direct sow date, and then the other half was the late March planting date. So I would use in each block I had the 3 different series, and then within each series the 3 different colors. So everything was equally represented. Same story out in the field with the added layer of the shade treatment compared to the full sun. So the Larkspur only grows annually, so I was able to kind of use the same spaces for the plants 2 years in a row. So with Larkspur and any plant that you're trying to direct sow, it's super tricky, right? So I made sure the direct sow at kind of almost 2 to 3 times greater than my desired rate. And then I would later thin these out to kind of the optimum density of about 36 plants per meter squared. So that's about a 6-inch spacing. So for researchers, it was kind of a really tedious thing to do. Whereas I think most growers wouldn't be as finicky about it. They would just kind of sow the seeds and not worry so much about that. But I irrigated using drip tape up to 3 times per week. Again, not as heavy of feeders as the Delphinium, but the Larkspur, I did up to 130 pounds of nitrogen per acre equivalent split up in 3 different applications, mid-March, mid-May, late June in the high tunnel, late March, mid-June, mid-July in the field. And then the phosphorus, potassium, and iron were just based off soil and tissue tests each season. So again, for the data collection, the air temperature and environment conditions were really important. So I had the reference air temperature at the weather station. I looked at the canopy air temperature hourly and then the soil temperature hourly. And that was logged from March through August in both systems. And then the stand counts were especially important for the larkspur just because there is so much variability with germination and the stand counts. So I would do that right after thinning and before harvest. So that kind of helped bolster the accuracy of my statistics work. So I harvested the larkspur 3 times per week. And with larkspur, I did that when about 1/4 to 1/3 of the racemes were open. Um, Again, the marketable stems were defoliated and stored at 36 degrees with preservative. And again, I sold these through local cooperatives and farmers who sold to markets along the Wasatch Front. And these were bunched, or bunches of larkspur range anywhere from $9 to $15 as well. So Larkspur, we lowered the standards a little bit on grading. So I had just 3 categories. The coal was anything less than 12 inches, not good. The standard was about 12 to 24 inches. And then the premium grade was the best Larkspur, anything greater than 2 feet. So interestingly, with Larkspur, it's important to remember that when you grow the plant, it'll produce a single primary stem. So you can harvest that, and that's usually a premium grade. If the plant's really tall, sometimes there's secondary stems that are growing down there below. And those could usually fall in the standard grade, but sometimes they're just coal as well. So again, looking at the environmental conditions from March through July when the larkspur was growing, I looked at the reference air temperature at the farm weather station, the canopy temperature in the high tunnel and field, along with the soil temperature and what the precipitation was. So remember that larkspur likes that temperature range of 60 to 70 degrees. So 2024, we had, again, a lot more temperature extremes from March to August. There were days that were greater than about 70 degrees Fahrenheit for over 1,100 hours in 2023, and then over 1,200 hours in 2024. So 2024 was a bit more rough. May through August, the days that were less than 60 degrees, um, there were 0 days, so it was pretty warm in 2023. But in 2024, there was 45 days. And we actually kind of had a freak freeze on May 24th, which kind of occurred later in the season in 2024. And we had a radiative frost that happened in June 18th, which was pretty problematic for a lot of plants. So just kind of the key takeaway from our temperature data was that 2024 had a lot more variability and it was a lot harder on the plants too, which I think kind of helps tell the story with what happened, especially with the marketable yield. So with this graph, we're looking at the cumulative marketable yield. So here we're actually looking at the number of stems per plant. So I chose to do stems per plant instead of stems per meter squared because it tells a better story about kind of just looking at the plant itself. Plus I had a lot of variability with germination too. So that makes the stems per meter squared kind of a more challenging metric to use. But we're looking at the 3 different colors, which are the 3 different series. Blue is the Cane series, green is the Fancy series, orange is the QIS series. The solid line represents the earlier planting date, or sorry, the earlier direct sow date, which was mid-March in the high tunnel, late April in the field. And then the dashed line is the later date, so late March in the high tunnel, and then early May in the field. And then the black symbols represent when the 10% of the harvest occurred, 50% of the harvest, and 90% of the harvest. So I think this kind of tells a cool story. So the high tunnel, we started harvest at the end of June, and that went all the way through about um, late July. But once that started wrapping up in the high tunnel, that's when the field larkspur started to happen or started to become available to harvest. And that went again from late July all the way through mid-August. So again, this is really cool to see how that staggered planting across both systems can give you that duration of Larkspur availability. So even though we didn't have as much Larkspur in the field as we did in the high tunnel, it's still good just to have kind of that almost season extension, if you will. So again, you can see how the temperatures had somewhat of a negative impact in 2024. But again, similar story where the high tunnel had higher yield than the field, and it also started a lot sooner. It was usually about that same time frame window as well. So looking at the total yield in terms, or I guess total and marketable yield. So this again is in stems per plant, and we're comparing the 2023 versus 2024 in the high tunnel. So the dark blue represents the premium grade stems, which for the most part was those primary, the initial Larkspur stems. Light blue represents the standard grade, which for most of the time was those secondary Larkspur stems. And then orange was coal, so anything less than 1 foot. So again, you can see how the temperatures extremes reduced the yields in 2024. And we really didn't see significant differences between the direct sow dates, but the earlier sow dates yielded more than the later ones. Also, the yields by series within the direct sow dates were similar in total and marketable yield. So we really didn't see a lot of significant difference between canes, fancy, and QIS. So looking at the field, same thing, but now we have the no shade plants and then the shaded plants as well. So kind of the cool thing, especially comparing the high tunnel to the field ones, is you'll notice that there's a lot more premium grade stems out in the field than there is in the high tunnel. And that's because out in the field, the plants, they were a lot shorter. So I was really only able just to harvest one stem per plant and get that minimum premium length. And there really wasn't a whole lot left over for those secondary standard grade lengths either. Um, and definitely not a whole lot left over for coals as well. So that's kind of a good visual understanding of why the field might have more of those premium grades as well. So again, this statistical significance was really variable. There's really no clear trend or story. Um, all three series kind of perform the same, but again, we see that the earlier late April direct sowed ones performed a little bit better than the early May ones as well. So for my research, I did kind of look at significance at the color level. I didn't report any of it here just because it got too in depth and a little bit too crazy. But colors within canes and QIS had pretty similar performance. But remember earlier how I was talking about within the fancy series that the belladonna, they only produce single blooms compared to the double blooms that we see with smoky eye and purple picotee. So that really could be shown mathematically well with the statistical significance. They significantly had higher yields, almost 2 to 3 times more. So, kind of a afterthought when I was analyzing this data was kind of looking at the planting density and how it had an effect on Larkspur. So this graph here, we're looking at the marketable yield in stems per plant versus what the plant density was. Again, so first years in the high tunnel, first year, first year in the high tunnel field and second year in the high tunnel and field of the research. So some takeaways from this are, or I guess I'll clarify. So the black symbols were the earlier planting date average, and then the gray symbols were the later planting date averages. So just some brief takeaways are that the yield was strongly influenced by the direct sow timing and the planting density. So in the high tunnel, you can see once the plant density increased, the yield started to increase or decrease as well. And that's most notable in the 2023 season. So based off that, we were kind of able to prove that the best recommendation is about 36 plants per meter squared for the Larkspur, especially in the high tunnel. But in the field, it's actually better to try to boost it up to about 40 plants per meter squared, just because the field has a lot more variability with temperature. It's not as protected. So having more plants is actually a little bit better. So this wasn't really the main focus of the research, but it was just kind of some interesting numbers to look at and kind of prove why the recommendations that are already out there work the best way. So kind of conclusion with the Larkspur was we found that high tunnels advance the harvest up to 2 weeks and the field earlier in the high tunnel and can prolong the field harvest by 2 weeks as well. So overall, that's about a 7 to 8 week duration of Larkspur, which is pretty cool. The mid-March direct sowing of the Larkspur in the high tunnel, that yielded the highest yield, had the best quality, and the best gross return. We got up to 5.5 marketable stems per plant. Um, and then the gross return was about close to $78 per meter squared. We found that the belladonna color within the Fancy series had the greatest survivability and productivity. And then, of course, we kind of were able to model those planting density recommendations as well. So kind of to wrap up, I just kind of want to talk about some extension programming goals I have here in South Dakota. So I really am excited to work with the Specialty Growers Association to host even more cut flower field days. I had the opportunity to go to one in the spring. And I know a lot of our West River growers, I think they would definitely be interested in hosting a field day. So that's something we could probably work to coordinate. So SDSU Extension, we're going to be hosting some cut flower camps. A lot of you might have participated in the one in the years past in the Sioux Falls area. So we're looking to expand that to also include Rapid Cities. So I also really want to see a lot of our growers work together, mobilize and organize, and put together these collectives and cooperatives and kind of try to start selling their flowers kind of at the wholesale bigger level as well. In Utah, there's a few cooperatives that have organized where a lot of farms would focus on producing kind of their niche flowers they were good at. They would bunch them up, bring them all to a warehouse once or twice a week, and they would sell wholesale where florists and other buyers would come and buy at these warehouses. So I think that would be kind of a really cool market opportunity, especially along that I-29 corridor where a lot of farms are already established. Um, I also want to work with a lot of our growers to help develop standards, especially for those wholesales. So figure out things like the best bunch sizes, stem lengths, pricing. Because I think for specialty cut flowers, a lot of that is just kind of location and market specific. So I shared a lot of what the Utah growers have developed, but that might look a little bit different here in South Dakota. And another important thing, I think, as growers, I know a lot of you are doing a great job of it already, but educating consumers, so florists, supermarkets, and buyers, and kind of really promoting the benefits of local specialty cut flowers. Because I think a lot of our growers were kind of competing with a lot of the imports that are flowing in from Europe and South America. And those have limitations. So I think that our local specialty cut flowers can fill in a lot of gaps in terms of like design, styles, and interests. But I think that's why it's really important to educate the consumers and buyers and kind of promote South Dakota cut flowers as well. The National Level Association of Specialty Cut Flower Growers, they're having their annual conference or biannual conference in Albuquerque this January. So I know I was at a regional conference last year and I actually met a South Dakota grower, which was fun. So I think it'd be really cool if any of you guys are interested in attending this conference in January to do that. And we actually have professional development and travel grants available through SARE. So that can help cover your plane ticket and the conference costs as well. So if you're wanting to go to this conference, reach out to me and I can help you guys write up that grant to get you out there. I was looking at plane prices for Rapid City Pier in Sioux Falls is about $400 to $500, which is a lot, but I think the grant can help cover that. If you fly out of Omaha, it's only $300 as well. So put that on your calendars and start thinking about possibly attending that as well. So in Utah, I did a lot with integrated pest management. So naturally, I kind of mended that with cut flowers. I think here in South Dakota too, there's a lot of limitations on cut flower pests and kind of understanding, but obviously IPM is super important. So I am looking forward when I do farm visits and working with you guys, kind of modeling what pests are, or even plant diseases are impacting our cut flowers as well. So here's just kind of like a graph I put together of all the different cut flowers and different pests that could impact them. So I definitely kind of want to continue building on this for our South Dakota growers as well. So lastly, I kind of want to work to develop a lot of resources too. So um, I can share with the associate or the cut flower growers here sometime my Delphinium, Larkspur, and cut flower pest fact sheets. So these are really comprehensive grower guides. So I made those at Utah State, but a lot of the information is definitely applicable here and can be used as well. I want to work with you guys as well to produce a lot more content. So South Dakota specific fact sheets, maybe a comprehensive guidebook, and maybe short form video content as well. So I think cut flowers here in South Dakota are still kind of a new thing, but there's so much potential and kind of exciting things that we could work on as well. So just to kind of wrap up everything, the key takeaways, it was a lot of information, but I want you guys to know that for delphiniums, early high tunnel transplanting, especially in late March, that will give you the highest yield of delphiniums. In the second year, you could get up to 70 stems per meter squared, 2 to 3 weeks earlier than in a field system. Staggered planting dates can extend your overall harvest window. I know as growers, it's really important for you guys to have continual supply of flowers available on demand when florists call or weddings, funerals, whatever events need them. For Larkspur, the mid-March high tunnel direct sowing, that'll give you the most stems per plant. Um, as early by late July, and high tunnels can also advance timing over field production as well. So just to kind of acknowledge everyone I worked with on this research and kind of the project funding as well. Cool. So what questions do you guys have or any comments?
If you don't want to unmute yourselves too, go ahead and put them in the chat and I'm happy to read them out loud. I think that was really interesting. We don't often dive into as research heavy or like scientific presentations in this group. So I'm curious, like if you only had a minute to tell a new flower grower who was going to start growing one of these varieties, what would be your quick tips?
Yeah, I would definitely recommend the belladonna hybrids for delphiniums. Those aren't as the big ones. I think sometimes the challenge with the big elatum types is they're almost too big and too gaudy. So it's more of a niche market. Those are harder to push, but growing those smaller belladonna types, there's a lot more possibilities for that as well. So definitely focus on that. Definitely do staggered transplanting, especially the first year. So again, if you have access to a high tunnel, do them as early as you can. If not, stagger your planting in the field as well, just to kind of extend that harvest window as well. And as growers, it's almost easier too, because if you plant them all at once, then you have to harvest them all at once. So kind of spacing them out allows kind of easier harvest, but also that extended window as well. For larkspur, I would definitely recommend direct sowing over transplanting. Some growers might even direct sow in the fall, and then the plants will come possibly even earlier in the springtime. I know direct sowing in the fall kind of um, there's risk because we don't know exactly what the winter weather will be like, and there's a lot less control over that too, but that's something that you could experiment as well. And I would also encourage, especially South Dakota growers too, to kind of figure out what the desired stem lengths are for your buyers and kind of what the market price is. Because I think right now it's really fluid and kind of unknown still. So kind of figuring out different models and standards would be cool.
And I was curious with that, and maybe you mentioned this, but for your kind of grading scale for your stem length and the premium,
Yeah.
was that based on just national research? Was that based on the local Utah growers that were growing the crops? Or how did you come up with those numbers? Just thinking about South Dakota growers that might
Yeah.
be trying to figure out what's considered premium and the pricing and stuff.
Yeah, so that was based completely off our local market. So it was kind of an average of what the different cooperatives in the state were expecting. also what different farmers were selling for. So they tend to mostly kind of be within the same range, but kind of be able to kind of just pinpoint and model those was how I picked them out. And again, that was just kind of what the Utah market was. I know there's a grower in the Seattle area who has kind of their own textbook of what they've done over the decades of selling flowers, with what their different grading is. Um, the USDA Boston Terminal Market, if you want to look at that resource, they have kind of what their stem length requirements are for the imports coming in from South America and Europe. Also, I think just talking to your local florist as well, kind of see, because they're the ones working with the flower, they want the long stem lengths to cut it and do whatever design work. So getting a good feel for what their expectations are can allow you as a grower to kind of have a bar to try to achieve as well.
Interesting. I think it's really cool that you found a market for the product of your research. I thought that was interesting, and I really agree with what you said about forming a cooperative. I don't know the number, but I mean the percentage of uh, cut flowers that are imported when we're growing them in South Dakota is very high.
Yeah, I think too, like I was saying, especially like in the eastern part of the state along that I-29 corridor, a lot of farms can get together, do like a wholesale once a week and maybe in the Sioux Falls. And then maybe West River, kind of more of the tourism area, try to find different wedding markets there as well. So lots of possibilities and options. So again, I think it'd be really cool to see our growers work together, organize and mobilize to do something.
I have a quick question. So I'm Tara,
Yeah,
I'm on the east side. I own 605 Petals and Pines. In regards to the pest management, I'm in my garden actually making
yeah.
bouquets. Is there any research, or are you working on the corn rootworm beetle?
Yeah, so we actually didn't have that in Utah, so I'm
No.
not familiar with it. We had the Western corn rootworm, mostly just again on corn crops. So
Okay.
I can definitely, I think I have your email, so I can send you
You do.
some videos and resources on that. And I can look too more on the cut flower side to see if anyone out there has been doing work on that or research.
Yeah.
So
I
I think
have
it's,
researched and I've talked to a lot of other and I've seen, many people talk about it, are the extension offices, and there's really nothing organic or no natural predator for it from what I can find.
yeah,
So it took out, I mean, not to exaggerate, like 60% of my zinnias probably at least. I mean, I just
wow,
know I'm going to lose a lot of flowers in
yeah,
the month of like August to September. The one thing I might try next year is like half of my flowers, I might do a foliar spray of molasses and try to
okay,
get the Brix levels up and see if that would help.
okay.
Kind of a
Yeah,
thought.
I'll do some digging too and try to find hopefully some helpful options and I'll reach out to you.
Sounds good. Thank
Yeah,
you.
pests are really challenging, especially with cut flowers, because they're not really a major crop. We don't know a lot of information. So it's good that you guys are keeping track of, okay, I'm seeing the beetle on X different plants and just kind of having a good understanding of different host plants, the time of year we're seeing them, and then that can help us kind of formulate some sort of integrated pest management plan.
Absolutely. Sounds good. Appreciate it.
Yeah, thank you.
It doesn't look like we've had any other questions come in, but thank you, Nick, for joining us and sharing about your research and all your tips.
Yeah, I'm thankful for the opportunity. So I'm looking forward to jumping in on more meetings as you have them and then participating more in field days. So if any of you guys have questions about cut flowers or more in depth, want resources, feel free to reach out and email me.